so now we are going to look at the final concept of collisions in 2D. And like I'm motivated, it's basically the same as collision in 1D, just doing it twice. Just like projectile motion, X and Y are going to be completely independent, and then you just basically double it. All right, so let's look at an example. We'll look at a billiard ball example where you have two billiard balls. Again, draw a before and after. Draw them slightly more separate. And this guy is going to stay still. This guy is going to move like this. So A, B, this is going to be at rest. And after, they are going to be moving at 45 degrees from each other. Okay, like this. So this guy's going to go this way. This guy's going to, so A is going to hit B, and let's say B goes this way, A goes this way. Okay, so this is now so this is what's called a glancing collision. So where in the point of contact, they probably look like this, right? So A didn't hit B head on. This is versus head-on collision. So with head-on collision, we know basically it's like a Newton's cradle situation, right? When A hits B head-on like this, but when it hits it at an angle, then the center of mass sort of lines up this way. This will cause this. So this is the contact force, right? The point of contact like this will create a normal force pushing this way, and this guy had some momentum going this way. So even though when there's a force this way, force is acceleration, so it just changes the velocity. So the velocity would go somewhere like this. This guy's initial velocity is 0, so it just accelerates purely in this way. So the velocity will be this way. Okay, so these are the terminology. Sometimes you'll hear people say head-on collisions and glancing collision. You know what that means. So we're going to use conservation of momentum, and you remember this is a vector law, right? It's a vector law. What does that mean? So that means if you sum all the the x components, sum all the px components, p initial, I don't know, p initial x component depends on how your grammar reads it, and the initial y components, that should equals to the summation of p final x components and final y components. Okay, so you can sum them, because when you add vectors, you add the components, as you know, right? So when I add, right, AI like this, so A1 plus A2, that just means A1x, A1y plus A2x, A2y, and that just means A1x plus A2x, A1y plus A2y. So that's sum of AX and sum of AY, right? So in some sense, the summation, even though if I break this into AIX, AIY, the summation can go in. So it's quick proof that I can just push the summation in here, save some board space. Otherwise, I'll write a separate line. But yeah, you can write a separate line if you would like. And now you see that this must equals to this. So what is that? That's the conservation of momentum with just the x components. And that's the conservation of momentum with just the y component. So all the y component momentum conserve, the x component momentum will conserve. Okay, so the long story short, you do x and y separately. Okay, so we'll build this up. At first, we'll look at the x components first. So at first, we'll label everything we need first. So we have MA, MB. I'm going to set MA equals to MB in my example shortly. But yeah, so this is UA. Let's say it's 3 meters per second going this way. UB, again, well, in a billiard ball table, that's going to be 0. And what I'm curious is about what is VA and what is VB. Okay, and assume that the way they collide has made them go 45 degrees like this. Okay, so again, let me set you the problem you should try. So you should try to write this down. As a variation number 1 is try if MA is not equals to MB. So let's say MA again is 2 and MB is 3. What will happen? And then try, now move them back to the same mass. Okay. Once they are the same mass, let's have this. Let's call this theta A and theta B. Here I had a simple case where they're just spreading out equally. And let's say theta A1 is 30 degrees and theta 2 is 60 degrees. Okay, see if you can solve this variation as well. Okay. All right. Back to the initial problem, the variation aside, do you have a guess of what will the velocities be over there? All right. So this guy was initially at rest. This guy's moving at 3 meters per second. They collide like this and they split out, okay, at 45 degrees. What do you think the velocities will be? Would they be the same or would they be different? If they're different, which one do you think will be faster? Okay, well, take a look. All right, so yeah, let's look at the x direction. So PA, so at first, let's write down I'll start from the beginning, right? So P initial, sum of all the P initial in the x direction is the sum of all the P final. Initially, normally I would just write that, right? But this time I'll have x like that, okay? So I will have, initially I have PAX plus PBX. And finally, I have, let's call it P prime A. So I'll label this, since I'm introducing new variables. Let's introduce, this guy has a momentum of PA. This guy has a momentum of PB. Technically it's 0, but it's fine. We're gonna set that 0. So this guy, it has a momentum of PA prime. So I'm gonna be curious of its VA, and I'm gonna be curious of its VB. These are my goals, right? So this guy is gonna have a momentum of PB prime, okay? Notice I've drawn the momentum vector the same direction as the velocity. Why? Because P is mv, right? So they point in the same direction. It's just, it just has a different length, but I'm not worrying about the length of that over there. Okay, so yeah, so it's PAX prime plus PBX prime, okay? So what can I learn over here? Well, this is MAUA plus MBUB. Okay, this is going to be, the U is going to be 0. And now I need to find the components of the x component of this. So we go back to our favorite thing to do, resolving vectors. In this case, it's not a force, but so P is this way, right? So we need to resolve into PAX prime and PAY prime. So just like SUVATs in 2D, you need to have a UX and UY, but this time it's PX and PY prime, right? This is 45 degrees, same as this, and we're gonna do the same. Resolve your P. Again, it's the object that has a momentum, so we're drawing the momentum arrow of the object from the center of momentum or center of mass of the object. Okay, so PBX prime, PBY prime, like this. Okay, so that's 45, so that's 45. Okay, so we have PAX prime. So I need this size, so it's the magnitude of that times cosine 45 because it's sandwiching it. Okay, so it's the magnitude of PAX. So sorry, magnitude of PA. What's the magnitude of PA? It's MA, right? So what's the magnitude of? So PA is equals to, or PA prime is equals to MAVA, right? So the magnitude of PA prime. Yeah, let me split it into a separate step so you can see, right? So PA prime X is PA prime cosine 45 degree. Make sense? Okay, so you resolve that there. And PBX is also, again, I'm using standard XY over here like this, okay? So that's PB prime times cosine 45 degrees because that's the one that's sandwiching the angle. Okay, so what's PA prime? The magnitude of PA prime? Well, m is going to be a positive number, so it's just the magnitude of this. So it's just MA VA, right? With the lazy notation. So here we have MA VA cosine 45 degrees plus MB VB. That's the magnitude, if you will. That's the magnitude of this. This is the magnitude of this cosine 45 degrees. And on the left, I have MA UA like this. Okay. Now, if my mass is the same, they also cancel. So let's write that as well. UA equals to VA cosine 45 degrees plus VB cosine 45 degrees. Okay. Now let's look at the y components. So take down the notes of the extra exercise for your own try. Okay, so that's the x equation. For the y equation, again, we'll do the same thing. So sum of P initial in the y direction must be the sum of P finals in the y direction. So initially, can we skip a few steps? Initially, what's the momentum in the y direction? Well, the momentum, as you can see, I should have drawn this here, since that's what's the momentum it is feeling. The momentum is momentum of the object, so it's from the center of mass of it. It's purely in the x direction. There's no y components, right? So the initial momentum of A in the y direction is 0. There's no y component to this vector. There's no even magnitude to this vector because it's not even moving, right? So PB. PB is MUB, like this, the initial, right? So, but this guy is 0. It's not even moving. So the whole y, what's the total y momentum initially? It's just 0. So you have 0 over here. So I'll just skip writing that down. Over here, now we need to actually do this. So PA y, so we have PA. Can we resolve this immediately? Yeah, let's resolve it immediately, right? So PA prime sine 45 degrees plus PB prime. Be careful, right? So yeah, let's not skip that step actually. So PA prime y plus PB prime y. But is this a plus or a minus? Let's see. So this is pointing in the negative y direction, right? So if I define my xy this way, then the y component of this is negative. Okay, in some sense, right? So PB, just to be clear, PA prime is PAX prime and PAY prime, but PB prime is positive PBX prime and negative PBY prime. Okay, so whatever that value is over here, you have a negative sign in front over here because it's pointing in the positive this amount in this direction and negative whatever this length. So I can calculate the magnitude of this, the length of this in this direction. So this is positive in this direction and positive in that direction. Okay, so that's why I have minus over here. And let's bring this up. So I have 0 equals to PA's magnitude, PA prime's magnitude times sine 45 degrees minus PB prime's magnitude times sine 45 degrees, like that, right? Okay, and now we can plug in the equation, the formula for it. So with MAVA, sine 45 minus MBVB sine 45 degrees. Remember the degrees as well. Whenever you write things that are degrees, otherwise it's radians. Okay, so be careful of that. And if the mass is the same thing. Let's simplify the mass as well. Because it's 0 on the other side, I can divide away the mass and I can divide away the sine 45 degrees. What does that tell me? So it tells me VA minus VB. What does that tell me? VA equals to VB. What's VA and VB again? That's the magnitude of the final A and final B. I don't know what it is, but I know that they're equal. I haven't found out what it is yet. I just found this tells me they're equal. But don't fear, right? I have two equations and two unknowns, so we're good, right? We can easily find it out. But immediately, even before I completed, it confirmed one of your suspicion, if that was indeed your suspicion, that these two speeds are the same, and that's due to the fact that these two angles are the same. Okay, so in the variation number 2, if you change the angles, you'll see what happens to the speed. Okay, so you can tell me that. Is it the same or is it different? Okay, so now I know VA equals to VB, all right? So we have two equations. From the X equations, I got this. From the Y equations, I got that. What do you do? Again, it begs you to substitute in here and eliminate it. So UA we do know, right? It's 3. So really the only unknowns is VA and VB, right? This is known. Okay, so let's plug that in, right? So UA, so if you want to present your solutions nicely, this is what you do. Write down 1, 2, and then you say plug 2 to 1. Okay, then you have, so it's very clear where everything's going. Now that you're getting better and better at physics, let's talk about presentation as well, right? So VA cosine 45 degrees plus VB is the same as VA, so I can just plug that in, right? It's VA cosine 45 degrees. Okay, what is that? Well, that's 2VA cosine 45 degrees. What is my goal? My goal is over VA, so let's make that the subject, isolate that. So that's UA over 2 cosine 45 degrees. And let's bring it up here. So we have VA equals to, now I can plug in the numbers. That's 3. Everything's in SI. That's the beauty of it. Cosine 45 degrees is 1 over root 2. Okay, so the answer is, again, write it vertically if possible, right? It's 3 root 2 over 2, like this. Okay, and I think you can plug it in the calculator and see what you get. I think it's roughly 2.1. Okay, so let's say everything is in 2 significant figures. Let's use whatever significant figures they're given. So 2.1 at the end, put it back. Okay, all right. Is that done? Have we solved the whole problem? We asked for VA and VB, all right? So don't forget to write also VB is equals to VA is 2.1. So yeah, so remember to, if that question asks VA and VB, don't forget to write. You can write VB equals to VA, but don't leave it over here and say, hey, grader, just look at what I have over there. Answer the questions properly. Okay. I don't know if you've left that out and you left that in there. I don't know will you get points or not. Depends on the mood of the grader, right? If they're being generous, maybe you will. If they feel like, well, you didn't really answer the question, I shouldn't be in charge of looking through your work and dig out, oh, in the middle, there's a step that is where the answer is. So it depends on the mood of your grader, and you don't want your final grade to depend on the mood of your grader, right? And in terms of proper presentation, you want to answer the questions properly. So yeah, that would be the most complete way to answer the question. So yeah, good. So we have covered almost everything. And maybe we'll do one more example, so to give you more confidence with this. We'll do a semi 1 and 2D example sort of mesh together and also combine with that idea of energy. And so you see how everything can sort of combine together, how useful this concept is in analyzing and making predictions. What we are going to do is hang a mass over here and shoot a bullet to it. Right? So we'll shoot a bullet to the mass and hang this over here, and this guy's gonna, get absorb the bullet into its piece of wood, let's say, and it's gonna get move a little bit, sort of swing a little bit higher. I'm curious how much or how high does this swing? Okay, so from this type of, we've learned the theory of collision, right? So in principle, I can make a prediction of that, and I can go out and do an experiment, go to Texas, buy a gun, and shoot this and give it a try, and you can see how accurate this is, right? Yeah, just to summarize, in 2D, it's really just, as you can see, the do the x momentum and x momentum, equate them together, do the y momentum, which in this case initially is 0. There's no y momentum, everything's moving in just a straight line and the x direction, and which means the y momentum of this guy must equals to y momentum of this guy. Right? Technically, there's a quicker way to get about this. It's just saying, hey, PBY prime must equals to PAY prime, right? That this arrow must cancel. It's like forces for momentum. Okay, yeah, and you can get PB. This is PB sine 45 degrees. This is PA prime sine 45 degrees. The 45 cancels. So you just have MB VB equals MA VA, right? The mass is the same, and I can immediately get that. That's another way to do it. So you don't need to set up an initial final. You can sort of just intuit your way, right? Just use your intuition. There's no momentum here, so these guys must cancel, and you can also do that. All right. We'll look at a final example, and that wraps up momentum.